Okay, so good morning all and welcome back to the session. This is Generative AI Learning Journey. Friends, in previous session, what we have discussed, we have gone through with the basics and we have majorly discussed about the lang chain. So, if we are talking about the steps with respect to the RAG chatbot, these are the steps what we have taken so far. We have seen we can have different large language models with the help of what we can build our RAG chatbots. Then creation of the chains we have seen with the help of LangChain basic functions. Moving further, what we have seen like how to write the effective prompts and all. So that we have seen, you can define the persona, you can restrict the outcome and all. So that these particular things we have seen with respect to the basics. Moving further, say if you are willing to design or create a RAG chatbot, then what you need to do, you need to have the documents. And documents might be of the different formats and it might be placed onto the different locations. So what you can do, you can utilize the loader functionality. Okay, with the help of what we will be able to load different types of documents. We have gone through with certain basics like if txt file is there, then what will happen to the loaded document? It will create only one document. If csv file is there, then it will create the documents with respect to the number of records available in that particular file. And if pdf file is there, it will create the documents, number of documents based upon the pages. These particular things are important from the interview perspective, so you should keep these particular things in your mind, how the documents are being created once you are having a particular format of the data. Okay, so that we have seen. Moving further, like we are having the documents now, we can't feed the laundry list to the large language model. It will uh, create certain issues like the outcome can hallucinate, the LLM need to run more time in order to extract the information from those particular documents, and it will lead to increase the latency as well. So what we need to do, we need to perform the chunking on top of that, and we have gone through with certain chunking mechanism. And recursive character text splitter is the one which is utilized inside the market. We can define we can define our own separators over there based upon the use case, based upon the data available. Like if hash is the separator utilized, then you can specify hash separator. If the full stop is the separator, you can specify full stop. If the comma is there, so it totally depends on you how you are going to define the separator. Now, what we are having these particular chunked data. The chunk data is available, and the next step what it will be the embedding. So I have created this particular notepad, sorry. So say loading files, then chunking, and then next step what it will be the embedding, and then relevant chunks, or you can say vector db. And from vector db we will be going to fetch certain relevant documents, and it will be passed to the llm. So we are talking about rag chatbot over here, track chatbot. So let's proceed with this particular step. Then we will be moving these particular chunks, embedding material into the vector DB. And from vector DB, we will be feeding certain documents, relevant documents. And we have talked about certain parameters, say search uh, K and search KW args. So we will be search type and search KW args. So we will be discussing about those parameters. And how those particular parameters are beneficial once we are working with the RAG chatbot in order to maintain the accuracy. So that is our agenda for the day, and let's proceed further. So what I will do, I am having a notebook already opened over here, and I have imported some set of libraries over here. So what I will do, uh, I will import one document, and based upon one document we will be moving further in order to have, say, chunking. Some of the steps, like, we will be copying from our previous notebook, and then we'll proceed for the embedding and all. So this is the file, this is the stuff what I'm having, and I'm going to use, say, this document. Let me copy. So text loader, I'm having this particular document, langchain text.txt. Yeah. So this is the document what I'm going to load, and I am going to use the splitting as well over here, and the recursive character text splitter I'm going to utilize in order to have the chunking on top of this particular file. So let me pick that particular stuff as well. Okay, so recursive character text splitter. Let me import with respect to that as well. So what I'm doing over here, this is the file langchain doc.txt, and I'm going to load it. So text loader is being utilized over here, text document, and I have loaded this. So loader.load, that is perfectly fine. In order to do the chunking, I'm having this particular import, and let's proceed for the chunking. So what I will do, I will define a splitter over here, and splitter, what it will be, say, chunk size, I can define 400, overlap this one, new line and all. So that is perfectly fine. Let me remove this full stop. Okay, this is the splitter in order to do the chunking, do the splitting of the document. And what I can have chunks equal to splitter dot split documents. I have pressed the tab key, split. So split documents, and I can pass this particular text doc over here that I'm having. So chunks, and let me try to print the length of these particular chunks. Length of chunks. So 78 chunks. And I would just want to show you something. Length of this text doc as well. So if I'm loading the text document, how many documents will be loaded initially? How many documents will be created initially? Guys, how many documents will be there initially for text file? Anyone? Yogendra, Nikhil, Lakshmi, Manish, Raj, Jalvin,
Four,
Vikas. How many documents will be there?
four,
Or
Uh-huh. One. What about
one,
others?
I guess.
Four text
So
document, four CSV file, or three PDF file.
No, no, no. We are having only TXT document. We have provided the path for the TXT document only. Yeah. Langchain doc.txt.
Okay.
So how many documents will
it's
be
one,
there?
I guess.
Hmm?
One.
One. That is correct. I will be having one document. And now I have done the chunking. And just have a look. At this moment, I'm having the 78 document, right?
Yes, yes.
Okay. So chunking portion is over. Correct? So what we are able to see, we are able to do the chunking for this particular data, and I'm having, say, let me try to mention it this particular way. I'm having langchain underscore doc.txt. This file was there, and what I have done, I have loaded this bit. Let me mention file only. So this is say one document. Once I have loaded it, over here one file. Once I have loaded it, it was the one file. Okay, but once I have done the chunking on top of this, it became how many files? 78 files, 78 documents basically. 78. And I just want to show you something else. So over here I have taken the chunk size 400. Let me if do say if chunk size is 800, so what will happen? And let me reduce the overlapping as well. So what will happen at this moment? The chunk size has been reduced. Once I have reduced the chunk size, the number once I have increased the chunk size, the number of documents reduced, right? Are you able to correlate?
Yeah, they are reducing.
Yes, because the size has been increased, right? Okay. Now, what I need to do, I need to do the embedding. So the next step, what it will be, the embeddings. And let me mention over here, embeddings. Create embeddings on top of these chunks. Okay, and guys, in order to do the embeddings, what we are going to use, we are going to utilize the OpenAI embeddings. And over here, inside the pricing, I will be able to see the embedding models as well. So image tokens, fine tuning, built in, and somewhere I will be having the embeddings. Video model, audio tokens, image tokens. Uh, I can go. Okay, let me move slowly. Okay, just have a look over here. Embedding models are there. So I'm going to pick the list one. So text embedding three small. So it is like I need to bear list cost for this. That is for 1 million token. I just need to pay $0.02 for the input, and for the batch cost it will be $0.01. So let me copy this, copy, and I will be utilizing it over here inside this. So this is the model what I'm going to use. Now what I will do, from LangChain underscore OpenAI, OpenAI import OpenAI embeddings. embeddings, and I just need to have chat open AI as well. Okay. Now, one more thing. Once I'm having the embeddings, I just need to store in a vector DB, and Chroma is the vector DB what I'm going to utilize for this particular step. So I just need to perform the embedding, OpenAI embedding, and if we are talking about the vector DB, so Chroma DB I'm going to utilize. Chroma DB. Okay, so Chroma I'm going to utilize, and over here OpenAI embedding. OpenAI embedding. Okay, so I'm going to leverage these particular things. So just have a look over here, OpenAI embedding, and from LangChain underscore community. From LangChain. Okay, so let me try to run import Chroma. Okay, so from LangChain community vector stores, import Chroma. Okay, so based upon the DB utilized, you can import that particular vector store, and then you will be able to utilize store your embeddings over there. So T3 small, this is the model that I'm going to use, embedding model basically. Now, what I need to do, I need to define the OpenAI embedding. I need to define the embedding model. OpenAI embedding and equal to OpenAI embedding. I just need to use this, and I will pass the model over here. Model equal to this one. So I am having this particular model, and let me run it. So OpenAI embedding model is defined. Now what I will do, create the vector store for OpenAI embedding. So I'm going to create the vector store as well. So just have a look over here, OpenAI, what I can say, vector store, OpenAI vector store. And what I will do, I will use this Chroma dot from, I have pressed the tab key, from documents, and I can pass the documents over here. So documents, and what are the documents over here for me? Documents are what? Chunks basically, right?
Yes, chunks.
Okay, so I will pass this particular chunks. Perfect. And I just need to provide, so I'm going to do the embeddings and move these particular embeddings into the vector store. So I am having the documents. I just need to specify the embedding model as well. Embedding equal to this OpenAI embedding, correct? And I can define a collection name basically. Collection name. Collection name is nothing but say database related thing. And I can say open AI and say store one. Okay, so OpenAI vector store, I have defined Chroma, things are looking fine. Let me do the execution. So the execution has been done. Now what I can do, let me try to mention something. Mhm. So what I can do, so at this moment, I'm having the embeddings inside this particular vector store, chroma. Okay, and like it will be stored there with the collection name, say Open AI Store. This will be the collection name over there, and chunks has been passed, and the model what I have defined over here, OpenAI embedding, in order to do the embeddings on top of this. You can think in this particular way. You have done the chunking and embedding. Now you are having the embeddings inside the vector store, right? You are having the embeddings inside the vector store. Now what you can do, if you are having a particular question, you can ask to LLM, and LLM will refer these particular embeddings which are stored inside this vector DB in order to provide the answer, okay. So just have a look over here. What I will do, I will ask a particular question. So what I will do, I can have a query, and I can define, say, what is LangChain. So I have defined this particular query. Now what I can do, open AI result I can have, and then open AI vector store I'm going to utilize, and dot I can have similarity search, and I can pass this particular query. Okay, so just have a look. I'm having the vector store. Inside this particular vector store, I'm having all the embeddings. On top of this, what I will do, I will perform the similarity search and pass this particular query, and I can have what? I can have k equal to 2. Okay, I just want to have the two responses. Okay, so this is perfectly fine, and I can do it in a good way. I for I in I comma doc in enumerate, and I can pass, say, OpenAI result comma 1 print. So this particular you can see stuff we have used in our previous session as well, and I can do a little bit formatting. OpenAI result, I can have I with respect to the document, new line, and then doc dot content, page content, and I can define the content up to this one, and let me try to run it. Name query is not defined. Where is, okay, I have not executed this. Now I have executed this. What is LangChain? Okay, so just have a look over here. LangChain, this is the outcome what I'm getting. LangChain introduction and the core philosophy, and LangChain for the data extraction. So over here, what I have defined k equal to 2, right? I have defined k equal to 2, so I'm getting these particular, you can say, result. Once I'm going to perform the query on top of this particular, you can say, embedding store, what I have defined over here. Just have a look, think for a minute and ask if you are having any doubt.
So actually, I have one question. Why we use k equal to two? Like why we choose two responses? Is there any reason?
Just to provide you the understanding, like if you use say 3, we will get 3 responses over here. Okay, 1
And all
2 and
responses are
3.
different.
Okay, if you mention 7, so you will get 7 responses, right? This is just a number. It will fetch that much of the records from the vector DB,
Okay,
right?
okay.
We are
And
performing
I
the
think all
similarity search.
responses are all responses are equal or different. I think
No, no, no.
equal.
These are the different one. Huh? These are the different one. Introduction, core philosophy, data extractions,
Okay,
LangChain memory, LangChain evaluation, LangChain long data.
okay,
Okay, right? LangChain with PDF, multi-modal applications. All the response are the different one. Huh?
So these answers
okay.
are based on the document you uploaded, or it's from the net.
No, no, no. This is from the document only. Huh? This
So
is
your
from the
document
document.
having the information about LangChain.
Yes, yes. Let me try to show. This is the document what we have used, LangChain text doc. This is the
Okay,
document what we have used, and just have a look over here.
right, right.
So LangChain
So
introduction and core philosophy, and just have a look over here, introduction and core philosophy, right?
right, right.
Then
In case if it
LangChain,
is not getting anything from document, it will get it from net, or
we
say that
just
it's not.
we need to do that particular stuff with the help of the prompting. We have not defined the prompts over here.
Right, right.
Okay, and prompt is not, you can say, not came into the picture so far, right? We have not done the prompting over here. We are trying to fetch certain documents from the vector store.
Mm.
Okay,
Okay.
and over here, is this the AND output? Can anybody tell me, is this the AND output? Hmm? AND output?
Now we need to forward this output to LLM, right?
Yes. Okay. So
Okay,
whatever
okay.
we are able to get at this moment, this is with respect to the embedding models only. Yeah. Like we have done the embeddings, and the user is having one query. So based upon the user query and the embeddings which are available inside the vector store, we are performing the similarity search, and we are identifying some documents, and these particular documents further will be given to LLM. Okay, so say we have 7 docs. Now at this moment, as we have defined the value of k equal to 7, so it has given me the 7 document. So these 7 documents will be given to large language model to frame the answer. At this moment, large language model is not utilized to provide the outcome based upon this particular question, right? We have not defined the chat model. Have you defined? No, we haven't defined the chat model so far. Correct? Let me try to give you more insight.
Are we recording this session?
Yeah, recording is going on.
Okay, okay. Sorry, I was not able to see.
Hmm.
Sorry.
Recording is going on. So just have a look over here. Let me chunk split open AI. This is the 10th one only. Okay, so just have a look. Chat model, we have defined GPT-5 Nano, but in this particular example, we haven't defined the chat model so far, right? Correct?
Correct. Actually, before embedding, I think we should define the LLM model, GPT-5
No.
Nano.
So our main intention over here is to get the understanding. Okay, so what is the normal process once you are uploading the files, loading the files, it will be then chunked, and then embedding will be done on top of those particular files. Once the embedding is done, it will be moved to the vector db. Now vector db is having the huge amount of data, and you are going to ask the question. So your query is given to this particular vector. You on top of your query as well, say the embedding is being happening. Okay, the query is also embedded. Now what will happen this, based upon this particular query and what is being stored inside the vector db, the similarity search will happen, okay. And based upon the similarity search, we are going to fetch some documents, and those particular documents will be given to the large language model. Okay, so it is depending upon us how many documents we need to fetch and provide to LLM to frame your answer, to draft your answer, right? So what we are doing over here, we are performing the similarity search and passing this particular query, okay, and fetching 7 documents. So it has given 7 documents. Now these particular 7 documents can be given to large language model to frame your answer. So large language model is not defined so far. Okay, we can define it over here and utilize it further. Okay, fine so far.
Yes, yes.
Yes.
Perfect. So we are having this particular stuff, that is perfectly fine.
Sure.
Now,
I have a que- I have a
mm-hmm,
question on here.
mm-hmm,
With the help of vector DB, we get this seven different kind of output.
mm-hmm,
So vector DB are using some kind of intelligence to make it there
hmm.
like
Let,
a
let, let me show,
LLM.
let me show. So what I can say data, and I can have this particular OpenAI vector store, and I just want to get what is there inside this vector DB. Yeah? So I just want to say include embeddings, embeddings, and say document and metadata. Embeddings, documents, and metadata. Include, okay. Let me have the single document only. Okay, so just have a look over here. These are the embeddings, huh? Right? So I'm having the document, I'm having the documents, and now what I have done the embeddings on top of that particular document. Huh? Okay, I have done the embeddings. Inside the vector DB, the data is stored into the in terms of vectors or the floating point numbers. We know it very well from the basics. We are able to recall from the initial sessions what we are able to get that the data, whatever is available, that will be stored in terms of embeddings, right? Inside the vector store. Is it fine so far? Are you able to
Yes, yes,
recall?
correct, correct,
Okay.
correct.
Yes.
And once we are having something in terms of vectors, then the searching will be very fast. Okay, the data is in high dimension, and the vector store are the specialized database in order to do that particular search with the low latency, so that we will be able to get the outcome uh, very fast, and the LLM based upon that particular outcome will be able to provide the answer to the queries. So that's why we are using vector DB over here to store the data in embeddings, right? And you are able to see over here, huh? So data stored in terms of embeddings over here, huh? Right? Is it fine with everyone?
Yes, yes.
Okay.
Yes, yes.
So these are the, you can say, IDs. You can take token IDs. This is the value, and this is the data on top of the embedding has happened, and at the end we will be able to see the metadata. So this is the metadata and all, huh? Right? So the data inside the vector DB is stored in terms of vectors, and like because of that only, because we need to perform the search very fast, so because of that reason only, we are storing it inside the vector store and fetching these particular records, which will be given to the large language model to frame your answer, huh? Our main motto to optimize this particular phase, huh? Okay, so searching will need to be happen very fast, and how many records I need to have. So we will be talking about this particular phase at this moment, huh? Right? We will be having the discussion onto this particular phase in order to have some optimization, like what are the different ways to fetch the records or documents from the from the vector store, and these particular documents will be given to the large language model to frame the answer. I'm repeating it again and again so that you will be having the clarity, right? Perfect. Fine,
I just
sir?
have I just have a small query.
Hmm?
Whenever it is fetching data from vector DB,
Mm-hmm.
so is it not doing any kind of grammatical mistakes handling things? Is it
No, no,
picking
no,
same
no,
as it is, right?
no, nothing over here. We are not utilizing the intelligence of large language model. Huh? Whatever
So
is
whatever
available,
whatever is mentioned in the document, it is picking as it is.
it is
All
picking as it is. Huh? Just have a
okay,
look.
okay,
Langchain introduction core philosophy. Huh? So it has picked the same from this particular document. Huh?
okay, okay.
Langchain intelligence is not
Additionally, it is
utilized.
not doing any thing means it's picking
Uh-huh.
as it is. Just the similarity
Just
search.
convert whatever is available into the embeddings and moved into the vector store.
Hmm.
Okay.
Okay.
Ashok, as
Mm-hmm.
we see in the mathematical model, so in this embedding, they are mapping this probability to vector, the vector DB, kind of a vector, right?
Mm-hmm.
And as we have a diagram model,
Mm-hmm.
so that kind of uh, making the words prediction of the words are happening in the vector DB, or it is a part of intelligence.
No, no, that is the part of intelligence. Huh? That is the part. You
It
can
is
think, you can think in this particular way. Let me. Okay. So I'm having LLM. LLM. So LLM is going to take some inputs, and based upon the input, it is going to provide us the outcome. So this is the input, and we are getting the output. Output. Okay. So input is there, and this is given to LLM, and we are getting the output. But in terms of RAG, this input is not the refined one. Okay. So what we are doing over here, we are passing the docs, okay, documents to large language model. Okay. It can utilize its intelligence or input, basically input, and not the input, what I can say, pre-trained data, pre-trained uh, info information, or data, what I can say, pre-trained data, okay, in order to provide the outcome. So you can think in this particular way. Once we are asking a particular question, and say we are having some query, and once we are asking a question, there are two ways, either like it three ways, what I can say. First, like it can utilize its pre-trained information, and what will happen, the query will be, you can say, mapped with the tokens which are available, and based upon the tokens, the weight, the distance is being calculated, and once the distance is being calculated, so based upon the nearer distance, it is going to fetch those particular words and given to large language model, and will be able to provide the output, right? Only distance measuring is being happening over here, right? So this is the normal way. Second way, we can have the documents, we can align LLM or instruct LLM that you need to take the reference of these particular documents in order to provide the answer to this particular query, so it will provide. Third way, what it will be, we can ask the data, we can ask the data from the you can say, we can give the query, provide some documents, and ask to utilize its intelligence as well, like pre-trained data, to provide the outcome. So there are three ways in order to answer the queries, but we know the weight change is not happening over here, the distance calculation is being happening, right? And who is doing this? LLM, correct? Whatever the weights we are having from the pre-trained, we will be going to have the discussion like how these pre-trained weights can be changed if the outcome is not up to the mark. So RAG is a stuff where the weights will remain same, we are getting the outcome. Next step, stuff what it will be, the fine tuning. Okay, so we will be discussing about the fine tuning. So we will be going to tune these particular weights. Fine tuning, probably it is clear, is it? So we are discussing about RAG where no weight is being changing. Probably I think you should have the clarity at this moment. Please ask if you are having still having the doubt. Is it fine with everyone? Yogendra, Manish, Nikhil, Javed.
Yes, yes, sir, yes, sir. Because sir, we are not using pre-trained model because our pre-trained models are not up to date. That's why we are using the RAG because we want answer
Pre-trained
from
models,
particular document only.
you are still confused. Pre-trained model, not pre-trained model is not there. Huh? Nothing is like pre-trained model. Model is there and pre-training is one
सर
phase inside the models.
सर एक बार इसे फिर से रिपीट कर दीजिए पूरा। ये यहाँ से मतलब ओनली एलएलएम के पास।
Okay, okay, LLM. So there are three ways in order to get the outcome. Once we are talking about the RAG, there are three ways to get the outcome. Get the output. Okay, so uh, using pre-trained data, using pre-trained data, using RAG docs, and using pre-trained data plus RAG docs. Okay, so there are three ways. Previously, we were not passing any document, but still we were able to get the outcome. Right? Again, we have passed some documents, but and based upon the documents, we are able to get the output. Third one is using pre-trained data plus the RAG documents in order to get the output. We mentioned that uh, and how we have controlled this particular stuff. Say you are telecom optimization engineer, and if you don't have the answer, use your intelligence to provide the output. Okay, so with the help of this particular prompt, what you are able to get, that large language model can utilize its intelligence in order to provide the outcome. And from where the intelligence will come into the picture, from the pre-trained data what it is having. So initially, once we are going to perform the pre-training of the large language model, we are capturing the parameters. You know, we have discussed about 175 billion parameters inside the GPT-5, GPT-3, and how those particular parameters are coming from the attention and MLP layer, right? Are you able to recall
Yes, sir.
58 billion?
But sir,
Mhm,
correct, sir. But sir, when we started the Ragna,
mhm.
we actually we are using RAG because particular pre-trained models is not having the information related particular documents like organizational data or
Correct, correct,
some
correct,
other.
correct.
We are using the RAG.
We are passing the context only. Okay, we are passing the context to large language model. Okay, we are passing.
So if we can ask a particular question related to particular documents when pre-trained model is not having the information, then is there any chance that LLM can provide the hallucinate output?
Correct. It
If we
can
ask
provide.
the like new
It
intelligence.
can provide the wrong output, okay, if it is not having the information about the organization document. Then what you have done, you have passed those particular documents as well. So it is having certain pre-trained information. It is not leveraging. What you have done, you have just you can say converted these particular documents into embedding, and that particular embedding is given to the large language model, refined one, after searching and all, that you need to provide the answer from this particular document, right? And it will uh, draft the answer based upon that only. No weight change is being happening over here, right? The weights of the initial model, the large language model, will remain same. Correct?
Yes.
Okay. Say, and same is happening with these particular things. Only the distance calculation is, you can say, is being done over here. So based upon the distance only, it is going to identify, and over here pre-trained data is being utilized in order to perform the distance calculation. So you can think into this particular way. You have given a document that is with respect to the Apple iPhone, right? And it might be possible inside the pre-trained data Apple is a fraud as well, but what it will do, it will calculate the distance of these particular embeddings based upon in order to draft the answer. It will utilize its intelligence, but not away from these particular documents if you have instructed it thoroughly. If you have not instructed, it might utilize its intelligence, and at that moment, even like once you are having the rags, the outcome may hallucinate, and rag is having an issue, the hallucination, because it is going to utilize its intelligence in order to provide the outcome. Okay, and at that moment, like based upon intelligence and mismatch inside the document, so the hallucination will come into the picture, right? Hallucination will be there, but how you are going to control the hallucination, we will be going through with the different optimization techniques. That's we are learning. Okay, let me repeat it once. So once we are trying to fetch the output from the large language model, there are the three ways. So using the pre-trained data, what it is having. So based upon the query, it is going to do the distance calculation from the weights and all. Okay, and provide the answer. We have seen the bigram language model, and we have seen the graphs initially with respect to the different dimensions, say boy, woman, man is there, so distance calculation is being happening, and based upon the distance we are able to get the output, and how the distance is being calculated. We have seen another example, like if Delhi is India, then Sydney is, it will be able to predict, say, Australia, right? Or Melbourne, Australia, you can say, right?
Yes, dot product and Euclidean distance method.
Yes, so same thing is being happening over here. Distance calculation, based upon the distance calculation, it is going to draft the answer, provide the output. It is not like, say, it is going to change the weights. Weight change is not happening over here.
So, sir, it is from pre-trained model, it is using the like attention mechanism and MLP layer, na, where like attention and MLP
Yes,
techniques.
definitely. It is going to use from those particular layers. But those are the pre-trained weights what we are having. Those particular faces are having the pre-trained weights, and we are just having the distance calculation. Correct?
Correct, correct.
Okay. There are two things probably which is confusing you. Say dimension is uh, I'm having dimension. Uh, Dimension is, say, mobile. Okay, dimension is mobile, and I'm having, say, Apple, and Apple is there, say. Okay, and with respect to the Apple, the weight is, say, 0.452123. Okay, Apple and say phone. Okay, so the dimension is, say, distance is 0.0002. Okay, now over here, uh, mobile is the dimension, right? And what it is having the values. So we will be having 122 double eight values with respect to the different, you can say, keywords, different tokens. So over here, say one mobile, which is the dimension, over here it is having distance of 0.4523, and another you can say is phone that is having triple distance 0002. So it is having the least distance. So in my, you can say, in my document or query, if like I'm saying say iPhone and all, or say Apple phone is there, so what it will do, it will pick this particular distance. It is not going to change, but it is going to pick the nearest one in order to provide the outcome, right? So distance, based upon the distance, the values are being picked, not like say values are being changed, right? We will be going to change these particular values, but during the fine tuning phase, fine tuning, or you can say pre-training. During the pre-training, these are the things. But now what we are having pre-trained data. So we are just going to pick the nearest one in order to draft the answer, or LLM is going to pick the nearest one in order to provide the answer. And because of this particular uh, check and pick, okay, or cherry pick, what I can say, uh, we are having the hallucination problem in RAG. Probably you are having the clarity at this moment. If yes, just say yes, or no, then I will repeat it once again.
Yes, yes, sir. Yes, sir.
Correct? All of you?
Yes, sir. Yes, sir. Okay.
Yes, yes.
Okay, perfect. So r- weights are not changed during the RAG, but we will be going to work onto the fine tuning where we are going to change these particular weights. Okay, so that will come in our upcoming sessions. So we will be going to perform the fine tuning. Now, if the documents are being changed, if the input documents are keep on changing, then fine tuning is not the correct way to perform or to move with. Okay, so fine tuning is done where you are having least frequency of change. You just tune the weight and you will be able to get the correct output. But if the documents are keep on changing, then you need to proceed for the changing. At that moment, these particular documents are not given, okay, these documents are not given. So what you do, based upon, say, this is from the user side, so you are having some documents and on, let me explain it. So the large language model, what is being happening, so large language model, I am querying to LLM and I'm getting the output. But based upon the query, say the query is with respect from the telecom domain, and its documents are not available inside the uh, are not there inside the pre-training phase. So definitely it will not provide the correct outcome. I will be getting the low quality outcome, or least quality output will be given by the large language model, or what I can say, the hallucinated output. We can't say it is correct or incorrect. So what we need to do at that moment, so we will use those particular documents, or we will use some labeled data labeled data will be used. And based upon the labeled data can be the document from the organization, the documents from the training and all, documents from different, you can say, uh, sources will be utilized in order to tune the weights. Okay, tune the weights of the large language model. And once the weight are tuned, then it will be able to differentiate based upon the Apple iPhone and say normal apple fruit. So distance, these particular distances will be tuned, and at that moment it will be able to pick the correct one. So the hallucination problem will be reduced, and the query and we will be given to say initially prefined before fine tuning, and what I can say incorrect output after fine tuning, correct output. Okay, so what has changed? The parameters, the parameters which are utilized in order to frame the answer, those has been changed over here. No external documents are being passed over here. External documents are given inside the RAG only. The stuff will remain same. Okay, query LLM and incorrect output before fine tuning, after fine tuning, query LLM and the correct output. Are you able to see the difference between RAG and fine tuning? Hmm? Is
Yes.
it
Yes.
Yes, yes.
correct? So if you are able to get 40 to 50% at this moment, that will be fine. Things will be more clear once we will be going through with the fine tuning phase. Okay, so RAG is utilized once the frequent data change is there, and fine tuning is utilized once the data change is not too much frequent, because the weights are being changed over here of the large language models, and the output is given based upon the changed weights, or you can say modified weights. And if the weights are modified, the output will be correct one, which is incorrect before the fine tuning, incorrect or hallucinated, what I can say, before the fine tuning. And it can be of full fine tuning or parameter efficient fine tuning. Full fine tuning, where all the weights are being changed, are changed, not being changed, are changed. Parameter efficient fine tuning, PEFT, where partial weights are being changed, where partial weights are changed. Okay, that is parameter efficient fine tuning. So full fine tuning is not the preferred approach, because over here it might be possible like the model will be completely changed. Definitely all the parameters, if all the parameters are changed, but it might lead to the incorrect or more hallucinated output. But once we are having the PEFT, parameter efficient fine tuning, we are going to change a small number of weights of the large language model, so that we will be able to get the correct output. So this is the preferred approach inside the industry. Like we will be tuning least number of weights, and then we will be able to get the correct output. So we'll be learning these particular things, and we will see practically how the implementation will happen. No need to worry. But the crux of this is RAG is utilized once the data change is not too much frequent, once the data is change is very frequent, and parameter efficient fine tuning is done once the data change is not too much frequent. Let me mention it as well. A frequent data change, RAG, least data change. And now you need to tell me You need to tell me if list data, why I can't do fine tuning on frequent data change. This is quite straightforward. Just think for a minute and tell me why I can't have fine tuning once the data is keep on changing. Huh?
Because it's costly to
Yeah, that is one
fine tuning
aspect. This is
LLM every time.
costly. But if like cost is not a concern, then what can be the reason?
Fast processing.
Mm,
If we do the
Actually,
fine tuning,
it will for fine
operation.
tuning, it will take the like so much of time and resources for every document we need to do the fine tuning. Then it is like we need to change lot of parameters every time.
So all
So
the inputs are correct, to be very frank, because like if your data is keep on changing, you need to keep on changing you need to proceed for the fine tuning again and again, and which is not recommended as well. Like if the data is being changing, so why you are keep on changing the large language model weights? So better try to proceed with the RAG approach where you just need to put the you can say documents inside the storage, and you will be able to get the outcome on top of that, right? So cost, time, each and everything will be used once you are going to perform the fine tuning. Okay.
as per my opinion, actually, maybe I am wrong.
Mm-hmm.
We are using RAG because we require a particular approach related to document because we not require generalized answers from LLM because RAG if we feeding particular documents to RAG, that means that documents are not easily available in internet domain or every models are not having that type of knowledge.
Mm-hmm.
So we require RAG for particular different knowledge which is limited knowledge
Mm-hmm.
kind of thing.
Mm-hmm. That is fine, but if you provide those particular documents inside the pre-training, okay, and change the weights of large language model, then definitely it will provide the answer, correct answer, based upon those
But
documents as well.
it will be time consuming and
Th-
like suppose that if we have
that's
like
what we are
in
discussing.
financial
Yeah, that's what
uh,
we are discussing. Okay, you can get the correct output, but from both of these two approaches, either RAG or either fine tuning. But when to use what, right? So RAG is opted once you are having the frequent data change, and uh, if the data change is not too much frequent, then you can proceed for the fine tuning. Both of these two solutions are going to remove the hallucination or to remove the generalized output. Correct?
correct, sir.
Okay. Okay. So let's move further. Mhm. Okay. So this is one aspect. Now, what I can do over here, we just perform the similarity search, and we are able to get that much document which we have mentioned over here. Now, once we are talking about, uh, so what we are doing over here, what we are doing over here, we are retrieving or fetching. Just focus over here from the vector DB. We are doing what? We are retrieving certain documents. Okay, in order to give those particular documents to the large language model to frame the answer. So we can define a retriever over here, okay, which is going to retrieve or fetch the documents, and that retrieval is controlled by two parameters. That retrieval is controlled by two parameters. Retrieval of documents from vector store is controlled by two parameters. Number one, search type, and number two, what it will be, search KWRs. Okay, search KWRs. That k equal to 3 is nothing but search KWRs. And we are having different values with respect to search type and search KWRs. So the first one is similarity search. A search type is similarity search. That we have seen, similarity search. And let me try to mention it over here. So I can define retriever1, and it will be OpenAI vector store, sorry, vector store, and dot as retriever. I can define retriever, and I can provide the parameters. Search type equal to I can define, say, similarity. Similarity search is being utilized, and search KWRs. Search KWRs, and what I can give, k equal to k, and I just need to pass in terms of, say, key and value k3. That is perfectly fine. And what I can do, docs equal to retriever dot invoke, and I can define the question, say, what is LangChain. Let me try to run it, and docs, length of docs, I just need to print it. Now, are you able to understand what we have done over here?
Yes, yes,
Huh?
yes. Yes, we have asked three type of responses, and now length of documents
We
three.
asked three documents in order to provide the outcome, and similarity search is being utilized over here, and search or KWRs means like I just want to have three document, and it has printed three document. We can check with this as well, like, say, for I and doc enumerate with result and all, so we will be able to see the outcome in a good formatting and all. So that is not our intention. Our intention is to get certain documents from the vector store. This is one way. Okay, now I just want to do some copy and paste. So these are the two parameters, what I have mentioned, and just have a look over here. So search type, choose the retrieval algorithm used to pick the documents from the vector store. Search type, right? So over here, similarity search, what it means, it is going to check based upon the query, it is going to check the documents inside the vector store, and based upon its you can say similarity or relevancy, it is going to fetch the top one and provide them. Search kw asks like that much documents dictionary containing the fine tuning control for how retrieval is being performed now. So it is going to fetch that much of the documents from the vector store. Moving further, uh, let's discuss about search type. So search type is further having the three main uh, algorithms. Let me try to pick and utilize it. Search type values. Okay. So search type values. So similarity we have seen return top k most similar chunks based purely onto the vector distance, right? Vector distance, based on the vector distance, it is going to pick up the top similar chunks, right? MMR, max marginal relevance, it will return relevance but diverse chunks by replacing the by reducing the redundancy. Yeah, let me try to explain it over here. Now, just have a look over here. LangChain introduction and core philosophy. Okay, LangChain integrate with large language model, retrieval augmented generation workflows, documents loading spotted and spotted files. you know uh, diversity. Yeah, diversity means like diversification inside the output, or it will not be sticking to the single one. We will be having the diversification inside the output. Say if we are talking about langchain, so one way is like langchain is this one. Langchain can provide the benefits to the large language. With the help of this, we can do n number of things. LangChain can make the life easy. Okay, so one is the simple, you can say, based upon the score and all, we will be able to get the output. Second one is it will thoroughly check the complete content, and it will try to add the diversifications. Like LangChain is uh, LangChain definition, its usage into the different domains, and then its benefit with respect to the the other tools and technology. Yeah, that can be one way. Okay, another another example, say if let me talk about the vegetables. Okay, so say potato is there, and if you are talking about like say what I can prepare with potato, so there might be the different things given inside the document, but based upon the similarity, it is going to check potatoes. Wherever the potato is there in the document, it will try to fetch the, but uh, there might not be the diversification now. So potato chips, potato finger fries and all, and potato pops, say these are the things which are prepared with the help of potato, and it is given in the document. Now, how can we have the diversifications? Like potato can prepare chips, potato can have the can be added with the vegetables, and then we can have uh, different cuisines with potatoes. Potato uh, can be boiled, potato can be fried, potato can be, you can say, used into the different, you can say, cuisines basically. Yeah. So what you can see, in the first way, we will be having the output. What I can say, that is not the incorrect one, but that will be the generalized one. But once we are having max marginal relevance, so it is going to have the diversification inside the output in order uh, to fetch those particular, you can say, records. And there is a score given with respect to each and every document, and based upon the relevancy it is going to pick those particular documents given to the large language model in order to provide the output. So max marginal relevance is going to add a diversification inside the output and provide you the good, you can say, output. Over here, because like what we are doing, we with the help of large language model we just need to have the diversified output, not the similar one or the generalized one. Although both of these two are coming from the documents only what you are going to upload, okay, but we just need to do a diversification inside the output, and for that we are using what? MMR, max marginal relevance, is the parameter what is being used in order to provide the output. Hope you all are clear what has been discussed so far. Max marginal relevance. Just think for a minute and ask if you are having any doubt.
It's equivalent to temperature that we see in our before session, right?
Huh. Yes, yes, yes. That is similar to the temperature, right? More or less. Correct?
Functionality is also same with temperature, sir.
Similarity, basically, say you can think in this particular way. You will be getting,
Functionality, yeah.
if you are mentioning say k equal to 3, you will be getting three documents, okay, with similarity score and with max marginal relevance, okay, with MMR. So you get three documents, but which documents are having the relevancy, max relevancy, that is given by MMR, okay. But over here similarity score will give you the top, or you can say k results based upon the similarity. Based upon the similarity it is going to provide the output. You can think in this particular way. uh, Say okay, so what I can say, uh, I'm having, say, document one, apples are rich in fiber and improved digestion. Let me move. with respect to this particular example. Apples help in weight loss. D3, D1, D2, D3, that is, these are the documents what I'm having. Apples contains what I can say antioxidant and vitamins. Then D4, document 4, banana provides bananas provides instant energy. And document 5, orange improve immunity. Okay. Now, once I'm going to ask the question now, say if I'm going to have the similarities, if I just want to have, uh, tell me about uh, benefits of eating fruits. Okay. So tell me about benefits of eating fruits. This is the query that I'm going to ask. Now, once I'm going to perform the similarity search, so document one, apples rich in fiber, that is perfectly fine. So I will be getting the document one. So then apples rich in fiber, document two is also fine. Then uh, then document 3, apples contains, that is perfectly fine. Similarity search will provide me the outcome in this particular way. But what we are missing over here, we are not having the diversity. Okay, diversity, what it means, like we are getting about the we are getting the information about the apple fruit only, right? Although like there are other documents as well in my you can say vector store, which are having the benefits of fruits, but with the help of this, the diversification is not there, huh? So what the mmr will do, so it will check all these particular, you can say, docs, and will add the relevancy score at each one, and then output will be based upon the relevancy. So d4 and d5 will be the output for the mmr. Both of these two are providing the benefits of eating fruits, but the similarity search is having the normal output. Okay, but mmr is having the diversification with respect to the fruits. Probably you get the context what I'm trying to say, huh? Is it clear now?
Yes, yes, yes.
So this one is having the diversification, both are providing the outcome with respect to the benefits of fruits, and we as a human being are expecting the most relevant data, not the similar data, right? Is it clear with everyone?
Correct, correct.
Perfect, huh? So let's proceed with these particular things. So we got three documents, huh? Now say retriever 2, I just want to have the retriever 2, and retriever onto the retriever 2, open AI vector store as a retriever, that is perfectly fine. Search type, what I can do, I can give mmr, max marginal relevance, kw args equal to, what I can have, k equal to 3, and then what I can have, fetch k fetch underscore k, and I can have say 15. Then I can have lambda mult, and I can have the value point say 5. Perfectly fine. And say k3, it will return top 5 or top 3, sorry, top 3 diverse result. Okay, fetch k, what it will do, fetch 15 and pick the best diverse dogs, diverse ones. Okay, okay, it will like, it will initially fetch top 15 and then it will have the diverse score and pick the best one, diverse one, which are having the diversification. So in our example, okay, it will fetch 15 and pick the 3, 1, 4 and 5 which are having the diverse output. Lambda mult, so I have given these particular, you can say, definition over here. Let me try to copy. Okay, search kwargs parameter, and I can paste it over here as well. Okay, so fetch k, number of the candidate documents retrieved before diversity filter. Lambda mult, control trade-off between similarity and diversity in the max marginal relevance. Okay, so it might be possible like similar and diverse, you can say, data I will be having. So what it will do, it will try to check like which one is more good. Okay, do I need to proceed for the diverse output? It is not like, say, if the diverse output is there, I'm going to provide the wrong output, wrong output. So it is going to control the, you can say, the trade-off between the similarity and diversity. Yeah, so that is lambda mult. And score threshold, it is minimum similarity score required for the document to be returned now. So say if we are defining zero point 0.5 as a minimum threshold, so the documents which are having less score than zero point 0.4, those will not be utilized. We are not going to fetch those particular document. Okay, so what I will do, I will run this and retriever 2, and then what I can do, docs 1 retriever 2 dot invoke, and what is langchain. Okay, and I can have, say, print length of docs1, so it will be 3 only because we have given k equal to 3 over here. So this is nothing but max marginal relevance. Over here the similarity search is there, and the third one is what, third one is we are having similarity score threshold. Let me try to copy the retriever 3 and the similarity score underscore threshold, and search kwargs k equal to 3, and I just need to give the score threshold. Score threshold, and I can give say 0.5 is the threshold, and k equal to 3, that is perfectly fine. I can invoke doc2 retriever 3, what is lang chain, and print length of doc2. It will be 3 only. Okay, so even you can print it in this particular way. We are having let me try to copy this one. For I doc in say docs2 and print doc, open a result. So you can check uh, the content. Let me try to. And what you need to do over here, what we have printed the documents, like after passing it from the different, you can say, retriever algorithms. It might be similarity search score threshold, it might be MMR, or it might be similarity. So what you need to do, you need to check the outcome from each and every, you can say, algorithm, and you just need to get the insight like how uh, it is looking like. So what is the difference between MMR, and what is the difference between the similarity search, what you are able to see over here. So just have a look and ask if you are having any doubts so far. Just have a look. Hmm.
So are these are documents using RAG optimization process. These are our parameters. Okay.
I didn't get what you are willing to ask.
These all parameters we are using in RAG optimization process, correct, sir?
Correct. These are used in RAG. Okay, so it might be possible. One, what is being happening over here? We are fetching certain records. What is normal practice inside the organization? So you are having documents, embedded documents inside the vector store. Now you try to fetch some documents. Now how many documents you need to fetch? Okay, what will be the similarity score? Is it based upon MMR, or is it based upon some threshold? So based upon tweaking these particular parameters, what we have discussed, say searching algorithm and searching parameters, you are going to capture the outcome. Over here we have not utilized LLM so far, so it will be, these particular documents will be given to LLM, and we got the answer. So we share that particular outcome based upon the parameters to the business to identify, like, is this correct one. From the developer's perspective, we try to think like you are developing a chatbot, and you are okay whatever you are getting, but if this is not as per the business recommendation, if the outcome is not as per the business recommendation based upon the query, then that is not making any sense. Okay, So what we guys are doing, we write down the parameter value, mention the question and mention the outcome as well, and give it to the business. Just verify is this particular outcome correct or not. So say you have given 10 variation of these particular parameters and they have selected one variation, that this in this particular variation the outcome is good. So you will do those particular settings. Okay, in our case we are say over here fetching 3 document 5 document, but we are fetching 100 documents, which are utilized in order to draft the answers. Okay, so 100 documents mmr is being utilized, max marginal relevance, uh, and the threshold is above zero point 0.5, so these are the setting for my organization chatbot that we have done in order to have the correct output from the chatbot, so these parameters are really very important in order to, you can say, tweak the output based upon these particular parameters, you can change it and definitely there will be change in output, right? So what you need to do, you need to do the practice by using these particular parameters. Filter is really very simple. You just need to mention filter in kwrks parameter, and you can avoid that I don't want to have the outcome from this. So you can say like you are having certain documents, you can take it in this particular way. You are having one document and inside that particular document you are having say RF optimization related stuff, but there are and the end user are from the RF optimization team, but this document containing the microwave optimization data as well. So what you can do, you can apply the filtration as well over there, and you can have the filtration of the required data, and rest of the data will not be utilized in order to provide the outcome, that will not be filtered. And if it is not filtered one, then the LLM will not get those particular output, and the output will be more refined, right? Are you able to get, all of you? Is it fine with everyone?
Yes, yes.
Yes, yes.
Okay, so I think we can conclude the session for the day. In the next session, we will be having the conversational chatbot. We will be going uh, to take one more step ahead, and we will be discussing about the conversational chatbot. But before that, you need to do the practice onto these particular parameters. Try to identify like what is being happening, so we have used certain prompts over here, not prompts but certain algorithms over here. So in the same fashion you just need to use and try to check like what is the difference between each one of them, okay. So in the next session, like these particular chunks will be given to large language model in order to frame the answer. And once like we are getting the outcome, then we'll start more optimization. Like over here, this is the normal way, okay, to fetch the documents from vector store and give it to the large language model. But there are many more optimization techniques that we will be discussing in order to have the more refined output from the large language model side, or less hallucinated output from the large language model side. So that will be covering in our upcoming session. Let me stop recording.